Hello, everyone. Before these slides pulling up, I can do a pretty brief introduction to everybody. My name is Runwei. I'm the assistant professor from the Department of Civil Engineering at New Mexico State University. At the same time, I'm also the part of the research team under Dr. Page's lead. So specifically, my background is in the feed and transport of environmental contaminants. So when last year, Dr. Xu came to me about this opportunity, I'm pretty excited about this, to see the alignment between my personal research interest as well as the research need from the consortium. So this project provides me with wonderful opportunities to contribute my expertise and experiences to the front line of New Mexico challenges. So during the past year of work, I just get aware that not every of my coworkers is necessarily have experiences about the feed and transport topic. So before we really dive into this specific topic, let's play a tiny game, all right? So let's just play some imagination tiny game, then we can get familiar about this concept. So in the next a few minutes, I will give you a description about my personal experiences, and then I will ask you guys to image those pictures. And then I will ask you to assume you are me in those pictures. So you guys ready? All right, so let's just say this is a day before the Thanksgiving, 11 p.m. in Dallas Airport, Terminal C, okay? I was in a trip to get reunion with my family in Indiana. However, unluckily, my first flight from El Paso to Dallas got delayed. So I missed my connection flight. And then now you are me, okay? So luckily, the airline company, they agreed to offer the hotel for me to rest. But to get that hotel, I need to take the shuttle, right? Apparently that day, yeah, thank you so much. Okay. So yeah, let's finish this little game. So that day, apparently, the Dallas hotel is pretty busy. And my flight is not the only one get delayed. So a bunch of people being offered a similar deal from the airlines. When I arrived at the shuttle station, I just realized that a whole bunch of people, like 20 people, who are going to go to those assigned hotel. But remember, it's like 11 p.m. at the night. So there's only one shuttle operating for multiple hotels for people assigned to. Now you are me with this bunch of people get into this car. It turns out my hotel is the last stop. In the coming 30 minutes drive, I see people coming down, get off when they arrive their designated hotel. In the end, when I get to my hotel, instead of a bunch of 20 people, only a few people with me, right? So the reason why I ask you to imagine these pictures is because the contaminants doing the same thing as we did. What is the transport, right? The transport is a community processes from point A to point B. Similarly, when the contaminants, they travel in the subsurface from releasing point, let's say, to the groundwater aquifer, that transports through it, just like we did in the shuttle. And instead of the vehicle driving us, the water flow driving the contaminants. Instead of the people getting off the shuttles, the contaminants being retained to the soil particle due to a series of different attenuation processes. So I hope this life-related example can build some common foundations for us that help you walk through the following slides. So this is the same disclaimer. Thanks for everybody, and I will just skip. And then I'll follow the similar outline that everybody used. And then get back to this study. It specifically focuses on the understanding of selected environmental contaminants in treated produced water when they travel through the subsurface. And also, we're going to assessing the related environmental and health related risk by comparing with the soil screening level developed followed by the MED guideline. So the outcome from this project will be crucial for managing the accidental spill or assessing the environmental feasibility for future application. So for the research method, I will stay at a pretty high level. Our major part is the middle part, is the transport experiment. So we are built up in soil columns. So when I say soil columns, you probably don't have the image. Let's just say this is a cup, and we fill this cup with the soil, and we injected those treated produced water from the top to the bottom, or either other ways, from one end to the other end. And we're going to observe the concentration of a selected environmental contaminants in those treated produced water over time. These patterns is going to give us insight about how these contaminants going to going to transport in the subsurface system. And before that, like during these transport processes, there's a very important or very dominant processes that are going to attenuate these, or going to retard the environmental contaminants in the soil. It's called adsorption. So this part will be studied separately besides the transport. And after the transport, we disassemble the soil columns and then extract those environmental contaminants being retained within the soil to develop the soil loading rate due to this transport. And then we're going to compare this soil loading rate with develop the soil screening level based on MED guideline. And then besides that, we have some additional tasks to support our whole project. And then some very basic information for you guys to know is that we selected a very specific treated produced water, thermal distillate treatment, and it have a higher occurrence of ammonia, benzene, and toluene, and these three specific environmental contaminants is being used as the target in our feed and transport study to give us a better understanding about how they're moved. And then for the soil, we have a specific agriculture soil from Artesia Center, and we also introduced a silicon sand as a reference medium. And we have some characterization I presented in the last December about the soil information that related to their general characteristic and feed and transport related characteristic. I'll just skip this part. Then is the adsorption study. So my major components results is being separated by four components. First one is adsorption, next one ammonia and transport, then is benzene toluene transport, then is soil screening levels. I will stop it after each section to give a take-home message. So in the first part, we have this adsorption study, which we combine a certain amount of a soil with different level of environmental contaminants we applied it to. And the maximum level is the occurrence of these environmental contaminants in the treated produced water. Turns out in the result, we can see a general increase of those adsorbed amounts for environmental contaminants on the soil as we increase the increase the solution level of environmental contaminants in the liquid phase. So we have this general increase for both ammonia and benzene toluene, but the differences existed between different type of contaminants. Ammonia have a much higher level as compared to benzene and toluene. So if we can see this XXL, maybe you cannot see it clearly, it's just too small. But let you know that for the benzene and toluene on this panel, for the XXL, the concentration of them is from 0 to 15 milligram per liter. But for the ammonia, we have this XXL from the 0 to 100 milligram per liter. So at a comparable concentration level, the adsorbed amount for benzene and toluene is at a level between 0.04 to 0.05 milligram per gram. Well, at the same level, the ammonia have already achieved like a 0.2 to 0.3, which is one other higher than what is achieved by the benzene and toluene. Then we fitted this adsorption results with a different isosen. So there are two major isosen we used here. First one is Luckmill isosen, second one is the Friendly. The major differences between them is their physical assumption. For Luckmill, we assume homogeneous adsorption during the all over the surface of the adsorbents. Well, from the Friendly, we assume differences. We assume variability for those adsorption side all over the adsorbents. And then for the ammonium adsorption result, both isosen works well. And we hypothesize that like this is a concentration related observation. In our treated produced water, the occurrence of ammonia is only at hundreds mg per liter. It's pretty high for treated produced water for the regulations, but it's much lower than the capacity of the soil that can absorb. So compared to the occurrence of ammonia in the solution, we have much more available absorption site from the soil. So they don't have to follow the differences for this absorption site. They just have a linear development for their absorption. Both isocyanates works well in this very initial stage. But differences we can observe for benzene and toluene. For benzene, although the log mu still gives satisfactory fitting performance, but we still see some off-chance over the fitted result and observed the result. So in this case, we see that the friendly isocyanate works slightly better than the log mu. I'll come back to this point later, because we observe the same thing for the toluene. So for those organic contaminants, friendly isocyanate works better than the ammonia. That is because they have followed a different mechanism for the absorption. For ammonia, they are positively charged. Their major mechanism for absorption is the electrostatic interaction between their positively charged and negatively charged the soil surface. So all over the surface of the soil, it's just like a negatively charged and positively charged. It's relatively homogeneous. And for the benzene and toluene, their absorption is much more due to the hydrophobic interaction between their self and the organic matters within the soil. But like in the soils, those organic matters is pretty different from site to site. Therefore, it will give a heterogeneous distribution for the absorption site that are going to trap benzene and toluene. So to wrap up, for the absorption studies, we have observed different levels, different absorption capacity for selecting the soil, for selecting the environmental contaminants. Ammonia have a higher level of absorption compared to benzene and toluene, and they are hypotheses that to go through different mechanisms for their absorption. Then we'll go through our transport experiment to further verify our suggestions. So first of all, we have this ammonia transport. So before I really dive into these results, I would like to have a better understanding about this curve. So in this figure, we have plotted the concentration of those selected environmental contaminants over time. So we have this transport. Remember, we have this soil column. We inject it from one end to the other end, and then we recorded those concentration of selected environmental contaminants over time at the other end. So just think about it. If we have this column, without filling anything, right? We have filling soil, we filling silicon sands, but if we filling nothing, this is just an empty column. What will happen? We just injected a background solution for like overnight, and we switch to the treated produced water for certain value. Then we switch the back. What will happen? We'll just have a very steep jump, right? It's just like a nothing at the flushing of the background solution. Then we have a jump to the level of the occurrence of environmental contaminants that in the treated produced water. And after we switch back to the background solution, they just disappear, right? So these patterns is kind of a transport being hindered by nothing. And it's pretty similar to what we observe in these white circle dots. Those are the transport patterns for the ammonia in a silicon sand, which means we use this silicon sand as the porous media, this ammonia have very limited retardation by the sand. But is that really saying the absorption did not occur in the silicon sand? I put a question mark here. But let's compare our next group of a transport experiment that we have tried to inject this treated produced water into a soil column rather than a sand column. And this data pattern, this transport pattern, is being represented by these black dots. So two very apparent differences can be observed. First one is their recovery. So we see this sharp decrease in their peaks And then in terms of the recovery in the effluents, for the sand column, we have recovered 96% of ammonia, but for the soil column, we only recovered 70%. The other major differences is that we see these very long tails, right? For the sand, it just stopped it after you switch back to the background solution, but for ammonia, it continuously eluted out. And this one is one of the major characteristics we assigned to so-called the kinetic absorption. Then we can come back to the previous question. Did the absorption not occur in the silicon sand? Not really. So in the absorption, we have two categories of them. We call it equilibrium absorption and kinetic absorption. Okay. So for the equilibrium absorption, it's more like the things goes up to the soil media and come back really quick. So in that case, we didn't see too much of a retention for the ammonia transport in the silicon column. So in this case, we can claim that in the soil, this ammonia is being retarded by their kinetic absorption processes mainly. Then other than that, for the rest of the 30% that retained in the soil, we want to know why. So we claim, we have investigated a few potential impact factors. One is from the indigenous soil bacteria. So we apply sodium enzyme, which is going to inhibit microbial activity within the soil. But it turns out we didn't see too much of the differences between the two transport with and without inhibitor. Then we can claim that the microbial activity have limited impacts on the transport of ammonia. Then we investigate the pH impact. We switch the pH from 8.6 in the original treated produced water to 7.0, which is common value for the irrigation water, and we do see a significant change for the transport pattern. It is because when we lower down the pH, the ammonia is much more existed in their trached form and therefore increased their retention in the soil column. Then we have our benzene and toluene transport. So the things we can see is that we have much more large retardation for benzene and toluene, but we see a much shorter tail after it's eluted out, which means their kinetic absorption is not is one of the impact factor, but may not as be dominant as for the ammonia. Then what will be the other impact? So we also try to see is that pH help, but really not. When we decrease in pH from 8.6 to 7.0, very similar pattern is being observed for benzene and toluene. It turns out the microbial activity could be the reason. With this microbial inhibitor added into the soil column, we see the boost of a facilitated eluting out of a benzene. But toluene does not have that much of a differences, and then we are hypothesizing that the amount of a microbial organism within the soil is not that much. Therefore, their capacity is only enough to dealing with benzene. If we have more enriched microorganism or less level of benzene and toluene, we could see a different chance. So then in the last step, we do a soil screening level development based on the MED guideline. It's being categorized by their health-related effects or non-health-related effect. So for health-related part, it can further subdivided into different land use. And it turns out for ammonia, we don't have too much of a potential health impact, and we don't have available regulation for that in the drinking water. So I just skip ammonia in this part. For benzene and toluene, it turns out like the soil loading rate resulted from our transport does not cause any concerns for health-related effects based on the soil screening level we developed it. And in the next one, we also developed the soil screening level for the groundwater based on the site information, soil information that we have for the artesia site, for the Permian Basin. In this case, our result is the soil loading rate exceeding certain soil screening level for certain DAF, which stands for our site capacity to attenuation the contamination. And in terms of toluene, it does not have concern for the groundwater, but for the benzene, we have a big concern for either tested the DAF scenario we have developed it. So to wrap it up, so in the batch absorption experiments, we have suggested a different mechanism for different environmental contaminants selected for this study. For the ammonia transport, we see that pH have a major impacts by changing the speciation of ammonia, but the microbial activity may have limited impact. Well, for the benzene toluene, the thing is the other way. Microbial activity may have much more impact compared to the pH. And then for the soils risk assessment, we do see there are certain specific concern for the groundwater compared to the health-related risk. So the upcoming result, we have Dr. Cho to talk about the sensitivity and uncertainty analysis. We also have the microbial community analysis coming up. And in the next phase, we're going to extend our study to other topics. All right, so finally, I would just give a shout to the funding agency. I appreciate this opportunity, and I appreciate the students that do this working on this project, and I also appreciate the CAL's help. Without you guys' efforts, we cannot achieve this with the characterization of environmental contaminants. Thank you.